Welcome everybody to part 15 of Senior Developer in 24 Hours. Today we're going to continue talking about code quality, in particular code quality tools. So what is the takeaway? After this video, you would have learned about static and dynamic analysis. We're going to understand the role and place of code quality tools, and we're going to see some of these tools in action. All right. So what is static analysis? Basically, static analysis focuses on the source code. It analyzes the structure and the syntax of the code. It doesn't require actually executing the code. And it can help us identify security vulnerabilities in the code. And actually, it can also help us identify issues on the dependencies. Some of the metrics that we can get from static analysis include things like lines of code, physical or logical, for example, whether we're including comments or not, cyclomatic complexity, basically a quantitative metric of how complex the code is, things like duplicated lines, code smells or possible bugs, and it can give us an approximation of technical debt in terms of how long would it take to fix the issues that are in our code base. There's a lot of static analysis tools. We have something there's a tool called PMD that covers Java, Kotlin, and some other JVM related languages, also JavaScript and some other more obscure languages. We have SonarQube, which we're going to be doing a demo, which covers a lot of the mainstream languages such as Java, .NET, PHP, Python, Node. Find bugs and spot bugs for TypeScript and JavaScript languages. PyLint for Python. ESLint for JavaScript and TypeScript. So, there are a lot of different tools that we can use. Some are bigger, have a broader scope. Others are a lot more specific and they have a much narrower scope. There are also dynamic analysis tools. This type of tooling actually requires the code to run. It requires the program to be executed for the analysis to take place. The most popular type of dynamic analysis is test coverage. And this is the one that you're going to run into the most. And basically test coverage works by instrumenting the code. There is two main ways in which we can instrument the code. One is ahead of time, which basically we run a process before we run the test. And also just in time, which when we're running the test, as our code is getting loaded, it gets instrumented. Once we have instrumented the code, we can run our unit test or integration test as usual. Because the code has been instrumented, special code has been added to collect the number of calls and which calls we're making. We're basically tracking every line that gets executed and how many times it gets executed. So at the end of the process, we can combine the results of the instrumentation with the source code to have an idea of which lines were covered, which branches were covered, which paths going through the code were covered. Now, beyond test coverage, there are other types of dynamic analysis that you might run into. Things like memory error detection, performance analysis, concurrency error detection, and so on. And with that said, let's do a demo of SonarQube, which is one of the most comprehensive tools that you can run into for static analysis and also a little bit of dynamic analysis. Let's see a demo. Let's see a demo of a tool that can help us measure the quality of our code and give us some quantitative metrics that we can use to keep track of whether we're trending in the right direction, whether we are trending in the wrong direction, and give us a little bit more insight into the code. This is going to help us look at the code again from the inside out. It's going to give us one perspective based on the actual code that we're working with, and this will help us understand a little bit how complex our code is, whether we have technical debt, how maintainable this code is going to be. So let's get started. With that said, I already have a local SonarQube instance that is ready to go, and I can go in and I can create a local project. The code base that I'm going to be examining today is a very small utility that I'm creating to showcase some of the examples that I'm creating for this overarching project of senior developer in 24 hours. So with that said, we enter some very basic information, basically the name of the project, a unique identifier for the project, what settings we're going to use. You can customize a lot the behavior of this tool, obviously, but we're going to go with the defaults. And with that said, we have created our project. Now, there's a lot of ways in which you can execute SonarQube. You can integrate it with your continuous integration tool, but for this particular example, we're going to run the analysis locally. So for this, we're going to create a token. And then now that we have this token, we have a few options depending on whether we are going to analyze a Maven project, Gradle project, .NET project, or for other languages. In this case, the tool that I'm working with is a TypeScript project. So we are going to have to use a standalone scanner that I can download and run locally against my code base. So I just need to copy this command. It already has the token at the end of the command. And with this, I will be able to run my analysis locally. Okay, this is my little application, very simple TypeScript application. One thing that I've done ahead of time is configuring a particular SonarQube property that tells me where the coverage information for my test is located. Again, this is a TypeScript code base, so I use Jest to run my unit test and also to generate the coverage report. And I just want to specify where those reports are going to be, because SonarQube is going to examine those coverage reports to help provide all of the information that SonarQube will give us. With that said, because we need the coverage information, the first thing I want to do is I want to run my test. I just have the npm test command set up. Should take only a second. Okay, now we have the test results, everything passed. We have the coverage information in the right place. I can go ahead and execute the analysis using the command that the SonarQube interface gave me. And here what we have is the project key, which is the identifier for our particular project, where the sources are located, the hosts that are going to, the SonarQube host where we're going to post the results of the analysis. Again, I'm running this local. This is why I'm hitting localhost port 9000. And then the token that is going to allow us to authenticate against SonarQube. So let's run this. It should take just a few seconds because this is a relatively small code base. Okay, great. Now that we have run our first analysis, let's go and see what SonarQube can tell us. Now, keep in mind that at this point, SonarQube has only done, SonarQube only has the record of one analysis. It only has the information about the code at one point in time. So in this, with this single point of information, we can see things like the maintainability. For example, right now we have 51 code smells. They're all relatively minor because we still have a pretty high rating here. We have no reliability bugs. We have no vulnerabilities. We have one security hotspot, and we can drill down into this. So for example, we can take a look at the code smells that we have. Again, relatively minor things, unused imports, commented out code, places where we should be using a primitive string as opposed to the wrapper, things like that. If we go into the security hotspot, what we have here is the beginning of Express application, which is not even close to being operational, but SonarQube has gone ahead and said, hey, this is something that you should be concerned about, because this is a framework that could potentially disclose important information that could be exploited by a malicious agent out there. If we could keep going down, we can see the presenting coverage for our code. Right now we have a coverage of 41.1. Not great, not terrible, but definitely something to improve. We have a little bit of duplicated code. And here we have the activity. Right now, the only thing that is reporting is that we've had one scan. Then we can go, see some of the other information. We can see the issues, security hotspots, which we've already looked at. We can see some metrics, for example, the number of bugs, securities, things like that. We can see some graphical representations of, where which are the classes that are most problematic. In this case, for example, we can see that runners.ts is the class that has the most lines of code, the most technical debt. So it's in the upper right-hand corner. Here we have some other classes that are somewhat big, but they have a lot less technical debt. So again, another way of looking at this to figure out where are the hotspots, where are the most significant classes in terms of maintainability issues or security issues, things like that. Again, similar representation for coverage. Duplications. We can see where the two obviously biggest blocks, because we only had two duplicated blocks. It's pretty easy to tell from this particular graphic representation where we have those duplications. We can see the size of our code base in terms of lines, statements, functions, things like that. We can also see the complexity of our code base. We can drill down here and see which are the most complex classes. Again, runners.ts is the most complicated class. It's the class that has the most maintainability issues and things like that. But this can help us determine, hey, do we have a class that is too big? Is there a class that we should break up? Or is it just, because we're working with very complicated things that we just have to work with it? All right. So what we've seen here is that coverage is not great. We do have some issues. So let me make some changes and let's run the scan again. So the first thing I'm going to do is I'm going to introduce a new unit test that will hopefully get our coverage a little bit higher. Right, so I've added a new unit test. Now we're ready to run this again. Again, the first thing I do is I run my test to make sure that we have updated coverage information, and then I run the scanner. Okay, and after the analysis is complete, then we'll be able to see how our code base is trending. So let's take a look at the SonarQube UI again. Okay, so after we run that second scan, we can see things like, for example, have we introduced new bugs from the original scan to the latest one? Have we introduced maintainability issues? Things like that. We can also see a trend, for example, here. We see that coverage has increased it has increased by 3.8%. Not a huge increase, but at least we're trending in the right direction. Duplications went down just slightly. We can also see the activity here. For example, in the first run, we had a 41.1% of coverage. Now we have a 44.9% of coverage. So here we can see if we're trending in the right direction. We can still see the overall snapshot of the latest version of the code. There's also a quality gate which can be configured. For example, if you introduce bugs, then you can have a quality gate that would fail, things like that. But overall, we're starting to build a comprehensive picture of our code throughout time. And that's important to understand the trends, to make sure that we're going in the right direction, make sure that we're not introducing technical debt, or if possible, hey, we're decreasing that technical debt. Speaking of which, I still have some smells, so let me take a minute to clean up some of that, and I'll run yet another scan. All right, I fixed some of the warnings that SonarQube was giving me, ready to run the scan yet again. And again, this is probably something that you want to automate within your CI system, but for now, running it local, at least it's going to give me the information that I need to understand my code base. All right, let's take a look at the results of the last analysis. What we see here, we have 3 different analyses. We can see the trends here, in particular the issues, which is what I was tackling with the last commit that I made. If you can see here, we started at 51 issues, went down to 49, then down to 28. So here we can see definitely a trend. We're trending in the right direction. We can see some of the other changes that we made. For example, code coverage started at 41, went up to 44.9. Now we're up to 47.2. And finally, the duplications started at 3.8. And then we made it all the way to 0. So definitely we can see some progress there. And these trends, at least in my opinion, are the most important part of the data that you can gather from a tool like this, because they help us see if we're going in the right direction or in the wrong direction, and if we have to correct the course. With that said, we shouldn't get hung up on things like maintainability issues and things like that. Even if we don't have a perfect code base, we should always try to improve constantly and prevent significant regressions. Obviously, when we're running into things like reliability and security vulnerabilities, we should address those in a timely fashion. But beyond those, focus on the trend, make sure that we are moving in the right direction. We can use the quality gate, which is going to tell us, for example, if we introduce bugs, if we introduce code that doesn't have the proper unit test, if we added duplicate code, things like that. We can use that to prevent technical debt from creeping into the code base. With that said, SonarQube is a very comprehensive tool, but there are other tools that are a lot simpler that can tell us more specific things in a much more narrow scope about the same thing, issues and metrics and things like that about our code. All right, so we just took a look at SonarQube, which is a very comprehensive tool. Now let's do another demo. This one is for ESLint, which is a much more narrower scope tool, much simpler to use, but that is also a valid tool to have in our toolbox, depending on the situation. Okay, there are tools that are self-contained and small in scope that we can also use to check our code for quality issues. For example, when we're talking about a project that is using TypeScript or JavaScript, we can use ESLint, which is probably the most popular standalone tool for TypeScript. And it's a very simple tool to use once you have it installed in your pack, in your modules. You can just call it using ESLint, then the directory where you want it to scan. And it's going to give you a lot of different recommendations that you can take a look and potentially fix. Of course, this is a tool that you can configure. In particular, this tool is configured in a file called eslint.rc.cjs. And here, for example, we are extending the recommended package, which is basically the default set of rules that ESLint comes with. And we are also extending the TypeScript specific recommended tools. So, you can also tailor this if you want to do something a little bit different, but out of the box, it will give you a lot of suggestions. Like I showed you before, it is going to help us identify things like variables not used, places where we should be declaring a constant instead of a variable, things like that. And we can even use the fix option to have the tool automatically fix any of the issues that are straightforward to change. So if we run the ESLint with the fix, we're going to see that some of the files have changed. So for example, we can take a look at what changes were made. Just one of the random files. So what is it doing here? For example, it went from using the object wrapper for string to just using regular strings. It is using constants instead of variables, things like that. So it's making the changes that it can do automatically that are safe to make without any user intervention. So, by passing the fix, you can get some of the work done automatically. There are others that you'll have to take a look manually and figure out, what is the best way forward. But such a tool will help you do a lot of the groundwork for you. And of course, we can also configure this as one of the scripts. For example, here I have it configured as the lint command and the lint fix. So I can also invoke these tools using my npm tool by doing npm run lint. Uh, so with this, for example, you can hook it up into your build process, your testing process, things like that. You can also hook it up into your Git hook, into your Git hooks, so that these things are run before you commit. So they give you a lot of flexibility. They're relatively lightweight, so you can integrate them better into your workflow, and they'll give you some, at least initial checking of some of the things you're doing in the code. All right, so now that I have all of this tooling, I have all of this uh, functionality, how do I fit this within my development workflow? And there are many places where you can fit them. For example, you can fit them as a Git hook, in particular the pre-commit hook. So for example, you can run some of the analysis, such as ESLint. Every time you're going to commit, before you can actually commit, you can run those tests, ensure that you're not creating new issues. And then if those checks pass, then you can go ahead and commit. You can also run them as part of your CI process. This will allow you to, for example, have gate checks before you move your code to higher environments, before people can merge their code, things like that. Plus, you also get a shared view of what people are working on, and it makes it easier to share information. And finally, you can also run them as standalone tools for any developer to run it locally. This works well for smaller teams, teams that work a lot more independently. So, um, these are tools that are at your disposal, and the best way for you to use them is in the way that works best for your team. Because at the end of the day, what we're trying to keep is the quality up. That is our main purpose. With this, what we're trying to do is we're trying to track the quality metrics over time. And when we have a big regression, when we have a big downward shift, we want to be able to notice that and be able to take action. We also want to keep the context in mind. Metrics for different projects might look very different. Things like cyclomatic complexity might look very different from one project to another. It might look very different from one team to another team. And both of them, they might be right. So this is something that has to work for your team. It has to work for your service. Change over time is probably more important than just a snapshot in time. What we want to do is we want to keep trending in the right direction. Now, remember that all of the metrics that we've been talking about, code smells, complexity, coverage, all of those things are only one way to look at your application or service. And this is an inside-out perspective. We're basically looking at the source code and we think, hey, if these metrics look good, then the result is going to be good. And normally that tracks, but it might not be the last word. You might have a great implementation for a design that doesn't really fit the requirements of your users. So at the end of the day, maybe your users are not as satisfied as you would expect them to be. In the reliability section, we're going to talk a completely different approach where we take a look at our service or application from the outside in, using things like SLIs and SLOs. And again, focus on the most critical issues first. We want to limit the increase of additional technical debt, but sometimes it's inevitable, and we don't want to stand in the way of progress. When we have time, when we have opportunities, we should take those opportunities to clean up the technical debt that we have accumulated. And don't obsess over every minor issue found by these reports. A lot of these reports, again, are very opinionated, and they might not, again, translate into something tangible like maintainability or reliability. Always prioritize the developer experience. You don't want your tooling to get in the way. We want to use the metrics for constructive purposes. Also, keep in mind that older code might have been written with different expectations, different styles, things like that. So, feel free to adjust some of the rules. Most of these tools come with default rules that are generally good, but they can be tailored to better address the needs of your team. So with that said, keep in mind that code quality tools help us make informed decisions regarding where to spend our effort. And you cannot really fix something if you don't measure it and you don't track it. So having these metrics is the first step to improving your code base. Please join us in our next video where we're going to be talking about writing and maintaining code, in particular, how do we maintain legacy code. And we're also going to talk about the role that generative AI, which is the hottest topic lately, not only in programming, but in pretty much everything that has to do with tech. How can we use generative AI as a tool for software development? Thank you for watching. Don't forget to subscribe. You can follow me on social media. And if you want to take a look at the work in progress book that is covering all of the material, look it up at srdevin24.com. Thank you. See you next week.